Alright, the third day of our chapter 10.3 has more operations. We have to learn a new rule that is very important when it comes to radicals, which is why I want you to write it. It's that radicals are not allowed in the denominator, in other words, in the bottom of a fraction. So if you ever have an answer, just like when we did our power properties, if you ended up with a negative exponent, it was wrong, that you had to move it and simplify it. Well, same thing here. If you ever get an answer and it has a radical on the bottom, you will now have to get rid of it, which I will show you how to do that. But again, the main rule, and this is for the majority of algebra, is that you are not allowed to have a radical at the bottom of the fraction. We will have to learn how to do what we call rationalizing the denominator. This just means that if we have a value with a radical at the bottom, we have to fix it using algebra. There is a way to fix it, but let's just talk real fast about how that works. So considering these problems real fast, square root of 2 times square root of 2. I'm just going to do this in the calculator to show you something and hope you see the pattern. Square root of 2, close parentheses, times square root of 2 equals 2. Square root of 6 times square root of 6. Square root of 6 times square root of 6 equals 6. Square root of 17 times square root of 17. And I hope you see the pattern right now. If you take a root times itself, pretty much what comes out is the number under the root. So if I was to ask you what square root of 10 times square root of 10 is, you should be able to see that the answer is 10. Just like if I ask you what's the square root of 14 times square root of 14, you should see the answer is 14. Just like if I ask you what's the square root of 193 times the square root of 193, you should know that it is 193. So that part is going to come in handy for us. Just make sure you understand that rule. If you take a root times itself, the number just comes out. Think again that the root comes out of 2, so there would be 2 2's underneath, which means that 1 2 comes out. 2 6's under, 1 6 comes out. But again, the overall thing you need to know for your own understanding is that when you take a root times itself, that the answer is pretty much going to be that number. Knowing how this works, think about whether this is a legal move algebraically. I have the number 3/4, and I multiply the top by 2 and the bottom by 2, and turn this into 3 times 2 being 6, 4 times 2 being 8. That is actually a legal thing there, because if you look at 3/4 in the beginning, 3 divided by 4 gives me the answer 0.75. If I look at 6 over 8, 6 divided by 8 is also 0.75. So again, what you have not done is change the value, you just change the way it looks. So you kind of rename this. Instead of 3/4, you turn into 6/8. Just like I could do 3/4, I can multiply by 6 on top, by 6 on the bottom, turn this into 18 over 24. Look at what 18 over 24 is, 0.75. So you can change the look of a number if you multiply both top and bottom by the same value. Again, think about algebra, where whenever you add 5 to the left, you have to add 5 to the right. It's the same thing here. As long as you treat the bottom and top of the fraction the same, then everything is legal. Alright? We will use this property with the following problems. And they are quick. They are very quick. They are very easy. But again, you have to remember the two things that I just told you. This is incorrect because we have a root 7 at the bottom. The way we get rid of a root 7 is by multiplying by root 7. But if I multiply by root 7 on the bottom, I also have to multiply by root 7 on the top. Again, root 7 over root 7 is the value of 1, which means that this is just multiplying by 1, but it's doing it in a way that I need. This turns into outside times outside, inside times inside, 21 root 7, and you should not have to do a bunch of work to know that root 7 times root 7 is 7. The last thing you have to do, though, is make sure this can't be reduced. So if you look at 21 over 7 and reduce it, you actually get the answer of 3 root 7. That is all. Okay? Looking at the second problem that we're talking about here, root 3 over root 5. The number that's wrong is at the bottom, the root 5. I don't care about a radical at the top. We just don't have a radical at the bottom. So what we're going to do is multiply by root 5 on the bottom and root 5 on the top. Again, this has a value of 1, which is legal. When I multiply these two, it's inside times inside, which makes root 15. 5 times, well, actually this here should just be a 5. And the same rule applies. We do not mix inside numbers with outside numbers. That is as far as I can go. I do not divide root 15 by 5 because this is an inside number and that's an outside number. And it's important that you keep remembering that you cannot mix inside numbers with outside numbers whenever you do multiplication and division. Alright? So thinking about it, these problems are overall very basic, but there is another type that's a bit more challenging. In order to do these problems, we're going to have to do what we say as conjugate, or find the conjugate of the denominator to make it work. So if I were asked you to find the conjugate of each expression, I'm just going to do this, and I think that you're smart enough to get what I'm doing. The conjugate of root 6 plus 7 is root 6 minus 7. The conjugate of 5 minus root 3 is 5 plus root 3. The conjugate of root 2 plus root 7 is root 2 minus root 7. And I want you to notice that all we did is switch the middle sign. This is necessary whenever we have two terms in the denominator. Think about the questions we just did. They had one term in the denominator the whole way through, and there was really nothing there. So you had a root 7 on the bottom, which is easy to deal with, a root 5 on the bottom, which is easy to deal with. But when you look at example 3, problem 3, you notice that there is a root at the bottom, but there is also a plus sign, and that is an issue. And so all we have to do to get rid of this is understand that in order to get rid of root 3 plus 4, that we will multiply by root 3 minus 4. But again, if I multiply by this on the bottom, I have to multiply by that same thing on the top, and this is where the distributive property we did yesterday comes in handy. 5 times root 3 is 5 root 3. 5 times negative 4 is minus 4. Now I'm not going to do the next step under here because this is a lot of work. Not a lot of work, but it takes a little while. So what I want to do is simply take this over here, root 3 plus 4 in parentheses, root 3 minus 4 in parentheses. I know that root 3, and this is again out of experience, root 3 times root 3 is 3. Minus 4 root 3 plus 4 root 3 minus 16. Notice that these two middle terms are opposites, which means they go away. And 3 minus 16 makes negative 13, which goes right here. Now there is one last step that you have to understand. Just like you can't have radicals at the bottom, you can't have negatives at the bottom. And so what we do is we simply take this thing and we change all three of these terms to be the opposite. So this turns into a negative 5 root 3, a positive 4, and a positive 13. And that is where we can stop. Now they might ask you to write 4 minus 5 root 3 over 13. Notice again 4 is positive, 5 root 3 is negative, 13 is positive, but both of those answers are acceptable. You just have to be careful again in doing this part. And again, what I suggest is that yes, even though this top part is pretty easy to do, that you do this multiplication of the bottom stuff somewhere else on the side of your scratch work to get that answer. You might notice a theme here in that you're having to do some scratch work in different locations, but again, that the theme here is that you are getting older, you are getting smarter, and you're starting to get into more grown-up math. And in order to do grown-up math, you have to be able to organize your work, you have to be able to slow down, and you have to be willing to not try to save space and save ink, that you might have to take some extra pages or extra ink, extra writing to get the answer right. Number 4, or problem 4, again, same thing. There's a radical on the bottom, but there's also a plus or minus sign. So we're going to multiply by 2 plus root 7 on the top and on the bottom. The top part is easy. 3 times 2 is 6, plus 3 root 7 goes here. Take these two things off to the side and work them out. Again, you should notice from the last part that it's not that hard. 2 times 2 is 4. 2 times root 7 is plus 2 root 7. This is minus 2 root 7, and root 7 times root 7 is negative first, but root 7 times root 7 is 7. This now, notice 2 root 7, negative 2 root 7 cancel out. 4 minus 7 is negative 3. Now there are two things wrong with this. The first thing being that we can't have a negative on the bottom, so remember we switch all the signs. This turns into negative 6 minus 3 root 7 all over positive 3. The second thing, if you look at these two numbers, 6 and 3, you can actually divide them both by 3. And so we will do that. 6 divided by 3 is 2. 3 divided by 3 is 1. That will be what they need you to understand. Now I know you're looking at this and saying there's no way I'll remember all that, but if you open your mind and allow yourself to be critiqued, which is what some of your weaknesses are, but if you allow yourself to be critiqued when it's wrong, you will be just fine. It's just new things and more things that you have to kind of think about as you work through this stuff. But if you bring me your work, if you bring me your computer and I tell you that it's wrong because of a certain step, just try to remember what I tell you. Part of you getting older is that if somebody tells you something once, you might have to ask them 1 or 2 more times, but the big issue is when you have to ask them 4, 5, 6, 7, 8, 9, 10 more times over the same thing. You are again getting older, you're smarter, you're becoming more responsible. It's time for you to accept that. Anyway, number 5, or problem 5, root 2 over 8 minus root 2. First thing again, we want to get rid of this on the bottom. We don't care about the top, but the bottom here, we want to multiply by 8 plus root 2. Remember, just change the middle sign, but that is on top and bottom. This multiplication here is 8 root 2, but pay attention here, root 2 times root 2 should be 2, because remember, a root times itself makes the number just come right on out. Again, over here we've got to do some work off to the side. 8 minus root 2 times 8 plus root 2, which gives me 64, plus 8 root 2 minus 8 root 2 minus root 2 times root 2 is 2. Here this and this cancel because they're opposites. 64 minus 2 is 62, and again you get that number there. And here is the last thing you need to think about. There's an 8 outside here, a 2 outside here, a 62 there. Remember, we don't consider the inside because these are all outside numbers. But we have 8, 2, and 62, which are all even, which means I can divide them all by 2, getting the answer of 4 root 2 plus 1 over 31 is where I would stop. Alright? So again, that is where you're going with this. I won't really, again, hurt you too much on your quiz if you forget that part, as long as you know how to get this far. But you just need to start making sure you pay attention to what is going on with that and how much you can simplify, how much is necessary for you to do. And again, before you go to get your credit, or before you move on to your Math Excel, please go ahead and do this question here. And then, as I said, go to your Math Excel, work on that. If you finish that and you have zeros or anything less than a 70 in the book, I'd say anything less than an 80 in the book, please continue working, because if you are caught talking and messing around and you have less than this 80 in the book, then I'm probably going to say something and you're probably not going to like what it sounds like. So other than that, go ahead and get to your job and do what you need to do, and let's go from there. Good luck.